자, 그럼 본격적으로 시작해 보도록 하겠습니다. 기조세션의 주제, 아마 국제우주정거장에 대해서 이 소식들 많이 알고 계실 텐데요. 우주 개발의 역사에 있어서 아주 중요한 터닝 포인트이기도 했죠. 자, 기조세션의 주제는 포스트-Iss 국제우주정거장 그 이후는 이라는 주제로 함께 이야기 나눠보도록 하겠습니다. 자, 이번 세션을 이끌어 주실 좌장님은 서울대학교 김종암 교수께서 함께 해 주시겠고요. 발표는 에리카 와그너 블루오리진 신흥시장개발 총괄이사께서 또 함께 해 주시겠습니다. 뿐만 아니라 올리비에 드베크 매사추세츠공과대학교 아폴로 프로그램 우주공학과 교수께서 발표 수고해 주시겠습니다. 사전 녹화 영상으로 또 오늘 함께 한다는 점 말씀드리면서 너른 양해 부탁을 드립니다. 자, 그럼 교수님을 단상에 모시고 저희는 기조 세션 시작해 보도록 하겠습니다. 여러분 박수로 환영해 주시기 바랍니다. 네, 부탁드립니다.
네, 안녕하십니까. 우주경제 빅뱅 호모스페이시언의 도전이라는 주제를 가지고 열리는 스트롱 코리아 포럼 2022에 참석해 주셔서 감사합니다. 저는 기조 세션을 맡은 김종암이고요. 현재 서울대학교 항공우주공학과에 재직하고 있습니다. 이분은 앉아서 말씀을 드리도록 하겠습니다. 오늘의 기조 세션은 포스트-Iss 국제우주정거장 그 이후는 이라는 주제로 진행됩니다. 국제우주정거장은 우주인의 거주가 가능하고 개별적인 모듈 형태로 구성된 일종의 거대한 저궤도 인공위성입니다. 1998년 이래로 국제우주정거장은 행성 간 탐사 임무에 따른 필수적인 우주비행체의 시스템 점검이라든가 다양한 과학 실험을 수행할 수 있는 우주 활동 공간을 제공해 왔습니다. 약 20여 년간의 임무를 마치고 다가오는 2030년 퇴역을 앞두고 있는 지금 세계 각국의 우주 커뮤니티는 뉴스페이스 시대를 맞이하여 우주의 상업적 활용과 생태계 구축을 목표로 하는 이른바 포스트-ISS를 준비하고 있습니다. 이와 관련해서 미 항공우주국 나사는 국제우주정거장을 대체하기 위해 이미 계약된 엑시움 스페이스사 이외에 세계의 상업용 민간 우주정거장 개발에 대한 제안을 공모한 바 있습니다. 그리고 지난 2021년 12월 2일 나사는 지구 저궤도에서 기업이 소유하고 상업적으로 운영될 민간 우주정거장 설계를 위해 블루오리진과 시에라 스페이스 주도로 개발 중인 오비탈 리프 프로젝트에 자금을 지원하기로 하였습니다. 나사의 상업용 저궤도 개발 프로그램은 지구 저궤도에서 수행되었던 다양한 탐사 및 연구 활동을 민간 분야로 이전하고 국제우주정거장이 퇴역하기 전에 민간 주도의 다양한 우주경제 활성화에 기여하는 것을 목표로 하고 있습니다. 현재 오비탈 리프 팀은 상업용 저궤도 개발 프로그램에 따라 나사와 협력하여 민간 우주정거장의 설계를 진행하고 있으며 2020년 후반에 올려질 예정인 오비탈 리프는 누구나 이용할 수 있는 복합 비즈니스 파크 우드 모델의 전형을 보여줄 것으로 기대하고 있습니다. 오늘 이와 관련해서 두 분의 연사를 모시고 기조 세션을 진행하겠습니다. 그런데 갑작스럽게 항공편이 연착되는 바람에 두 번째 연사이신 드베크 교수님께서는 질의응답에 직접 참여하는 것은 아마 어려울 것으로 예상됩니다. 그래서 세션 형식을 잠시 조정을 해가지고 질의응답은 와그너 박사님과 함께 진행을 하도록 하겠습니다. 갑작스러운 일정 변경 양해 부탁드리겠습니다. 연사 소개해드리면 첫 번째 연사는 블루오리진의 신흥시장개발 총괄이사인 에리카 와그너 박사로 현재 오비탈 리프 프로젝트의 리더를 맡고 있습니다. 와그너 박사님은 반더빌트 대학에서 의생명공학을 전공한 이후 MIT에서 항공우주공학으로 석사학위를, 하버드 MIT 건강과학 및 기술분과에서 우주생리학으로 박사학위를 취득하셨습니다. 주로 다양한 중력 환경에서 인간과 포유류 생리적 영향 및 적응력 등을 연구하고 있으며 그간 Commercial Spaceflight Federation, American Society for Gravitational and Space Research, 나사의 Planetary Protection Independent Review Board 등 다양한 기관에서 자문과 이사직을 역임한 바 있습니다. 두 번째 연사는 매사추세츠공과대학 우주공학과의 아폴로 프로그램 교수로 재직 중인 올리비에 드베크 박사입니다. 올리비에 드베크 교수님은 쭈리 공과대학에서 산업공학 학사, MIT에서 항공우주 시스템 석사 및 박사 학위를 받았고 현재 MIT 엔지니어링 시스템 연구소 소장을 맡고 있습니다. 주로 인공위성과 발사체의 시스템 설계 및 최적화에 대한 연구를 수행해 왔으며 행성 간 공급망 개념을 수립하는 데 기여했고 2004년 이래 다수 논문을 발표하며 12차례 최우수 논문상을 수상한 바 있습니다. 드베크 교수님은 연구와 교육을 통해 지구 삶을 개선하고 인류의 외교 정책에 기여하는 것을 목표로 삼고 있다고 합니다. 이상으로 세션 주제와 연사 소개를 간략히 마치고 먼저 에리카 와그너 박사님께서 오비탈 리프 스페이스 스테이션에 대해서 말씀해 주시겠습니다. So Dr. Erika Wagner, could you please proceed your presentations?
Thank you so very much. It's a pleasure to be here and to be here with you all. I am delighted to share what is going on with the Orbital Reef Space Station. As the professor mentioned, this is a part of NASA's Commercial LEO Destinations program, but also a commercial space station in its own right that is designed to welcome the world into low Earth orbit. When we talk about orbital reef, we talk about it as an ecosystem, just like a coral reef here in the oceans. That an orbital reef is something that grows from small contributions into a very vibrant community of users that come offering their own pieces to what the world is doing in space. And we look forward to doing that with Korea. Now, if I can show my slides, it was placed into orbit, continuously operated and occupied by humans for more than 20 years. It has been home to more than 3,000 experiments and more than 200 humans. And yet it is one of the most astounding accomplishments of humanity, both in scale and in investment. When we think about what is possible in space, we look at this as a starting point. We also look at it a little bit like I look at my children's bedroom. It has gotten very crowded. It has gotten very full. And when we look at what is happening inside the space station, it is perhaps less inspiring as a home for enterprise and research than it is a little bit crowded and cramped. When I think about space stations, I like to think about something that is more expansive and more welcoming. Perhaps you think of the 2001 A Space Odyssey and Stanley Kubrick's version of what was possible in space. Something that was inspirational, something that was open, something that was welcoming. The Orbital Reef Space Station is designed to be a home for the world in space, to welcome commercial users, government users, industrial users, consumer users. And when we think about what's possible, it is a vision that is that grows as our visions grow. It is a home that can grow with the markets, and it's a home that can grow with the infrastructure. Our core module is a hallway down the middle of the space station with some of the biggest windows ever made in space. Those windows are facing the Earth, our home away from home. But really what this core module is, it is the basis for growth. It is the infrastructure that allows for a business park, a university to grow in space. So what this module provides is the power, the thermal control, the communications, It allows us to have the support for all sorts of things to add on to the sides of the core module and to grow with their own applications. In many ways, we think of this as a business park in space. And that might not be the most visionary explanation of what is going on, but I think it is important to start to understand that what is happening in space is more and more like what is happening on the ground. Historically, we have thought about space companies as few and far between. And yet, almost every company today is reliant on space for what it is doing, whether that's for communications, or for Earth observation, or for data. As we move into the next generation of space utilization, it is increasingly incumbent upon us all to think of our companies as space companies. So this commercially developed, owned, and operated station in low Earth orbit is not ISS 2.0. It really is something rather different. It relies on a long-term vision of developing and operating infrastructure that supports the growth of humans living and working in space. That architecture, as it grows modularly, allows us to keep pace with market demands for government users, industrial users, and consumer users. What we've really been focused on in the design of this space station is efficiency. The International Space Station was designed to be very, very effective, but not always very, very efficient. And when we think about this as a commercial business, we really have to start thinking about logistics and how do we re-envision the way that we operate a space station? How do we grow so that we can continue to have more and more users come and join us on the space station? And how are we international with a capital I? How do we really make this a global place to do business? Part of what allows us to do this is modular growth. And you see on the left our baseline configuration. This is the space station we have begun working with NASA on through the Commercial LEO Destinations program. It is designed to launch in the late 2020s and to be operational before the International Space Station comes to the end of its life. Now, it may look small with just 3 modules, but those modules rely on the New Glenn launch vehicle, which has a 7-meter fairing, allowing us to have modules that are almost twice the size of what we are used to with traditional 5-meter fairings. This means that the baseline configuration of the orbital reef is nearly 90% of the volume of the International Space Station. Now, as those markets grow, we have the ability to grow additional core modules, additional customer modules that allow us to expand that vision. So what starts off as a home for research and development, as we've seen on the ISS, then grows to include more and more commercial markets. So by the mid-2030s, or as the markets allow, we can expand to have not just 10 astronauts on our baseline configuration, but tens of astronauts, and ultimately hundreds of astronauts per year if the markets are supportive. To do this, we need an incredible team. And as you may have seen in our video between the sessions, we are a strategic partnership between Blue Origin and Sierra Space, 2 companies with a very strong commercial vision for the future of space. We're joined by teammates from across the industry that bring their own expertise. Boeing, with more than 20 years of experience operating and maintaining the International Space Station. Redwire, with its Made in Space and TechShot portfolio, allowing us to support new kinds of researchers and more in-space manufacturing. Genesis Engineering, which has a single-person spacecraft that allows for extravehicular activity without spacesuits. Arizona State University is a consortium of more than a dozen universities around the world, working with us to make sure that we are opening our doors wider and wider for academic use. And Amazon and AWS are really some of the world's leaders in logistics and are helping us to reimagine logistics for a future in space. Together, this team creates 4 transportation elements, as you see on the left: the New Glenn launch vehicle, the Dream Chaser and Starliner spacecraft, and a space tug that helps us with operations. And 6 destination elements: the core module by Blue Origin, the research module in collaboration with Boeing, the life habitat built by Sierra Space. The energy mast provides both power and thermal management in many of the functions of the spacecraft. The node allows us to have spacecraft docking to the space station and visiting vehicles to come up and to join our operations. And as I mentioned, that single-person spacecraft allows for both maintenance and commercial activities. We have been very focused on creating a space station that we want to live and work in, one that really centers the users in its design and its implementation. You see these wide open spaces, and that's both practical and beautiful. I think that that's actually important, that we think about how are we creating a space that allows us to support not just research, but also consumer activities like tourism, the filming of movies, the applications of art and design in space. If you look from left to right across our baseline configuration, you can now see these modules in cross-section. The node on the left, providing, again, EVA and docking ports. The inflatable life habitat, really expanding to create quite a bit of volume for human living, eating, communal activities, as well as research. The core and mast in the center, that round module, are, again, what provides the infrastructure for everything else. And the research module on the right-hand side supports both traditional research, doing life sciences and materials sciences, physical sciences, as well as production of in-space manufacturing. So we're really hoping that this baseline configuration, again, 90% of the volume of the International Space Station, is the springboard for many, many other applications. When we look at the markets that we think are growing, we are investing very heavily right now in thinking about the growth from traditional markets of national research, space agencies around the world, and exploration services. I think it's very important that we don't think about low Earth orbit as an alternative to what's happening in deeper space exploration, but really the support that allows us to go to the moon and Mars and beyond. We're going to continue to need a vibrant support of technology maturation and astronaut training in low Earth orbit. Satellites have traditionally been launched from the ground with having to withstand the loads of their launch vehicles. But a platform like this allows us to have human-tended operations that can prepare, recycle, and even deploy spacecraft from orbit. Commercial industry can grow materials. It can create new products, both for use in the in-space economy as well as terrestrial applications. And our partners at Redwire have really been innovators in this space, both with fiber optic cable development, as well as pharmacological and biomanufacturing. Consumer productions really have not had a home on the International Space Station, and that's been appropriate. It's a government facility that's designed for government and national applications. But as we move into the commercial world, we start to see more opportunities opening up for content, entertainment, media, advertising, as well as that last bullet, travel and tourism. Our New Shepard spacecraft, which has begun to take people into space on a regular basis from the deserts of West Texas, has shown us that there's a vibrant marketplace for private space travel, and that it is continually surprising us in the kinds of individuals that are coming out to join us and the kinds of dreams that they have of the future, the noble causes and personal journeys they're embarking upon, as well as just the incredible experience of a once-in-a-lifetime journey. So we see all 6 of these markets as important, and ones that we are designing our business and our infrastructure to accommodate. So I mentioned that orbital reef is a different scale, and I mean that physically as well as sort of emotionally and from a business standpoint. That core module launched again on New Glenn with a 7-meter fairing is almost twice as big as a traditional module on the International Space Station. You can see these almost side by side in scale and proportion. This allows us to think about our facilities as architecture, to zone as appropriate for the different kinds of functionality, as well as to really open up the possibilities of the kinds of things that you can do in space. When you have very small volumes to work in, you are limited in the kinds of things you can manufacture. You're limited in the kinds of research you conduct. As we expand that space, we expand our possibilities. My last slide here, just again, bringing us back to the markets. The Orbital Reef Space Station is a commercial facility, and Blue Origin and Sierra Space are committed to creating an ecosystem in which all sorts of users are welcome and able to grow with us. That large volume supports a lot of possibilities for doing business in different ways, for conducting research at a different scale. The focus on the customer experience starts from the minute you interact with the Orbital Reef team and it continues through your training, your transportation, your onboard applications, and your post-flight experiences. We're really focused on how do we make this space station very, very customer-centric. And it is designed for collaboration. We look forward to there being a module from the South Korean enterprises that are coming perhaps jointly between a space station, a space agency rather, and a new space company. We look forward to flying astronauts from across the region. And we look forward to collaborating to create possibilities for arts, entertainment, design, and manufacturing. So with that, I will say thank you very much again for having me. The Orbital Reef has a vision of being welcoming to the whole world, and we hope that you will join us. Thank you so much.
Thanks, Dr. Wagner, for a very interesting and exciting presentation. 와그너 박사님의 발표를 바탕으로 지금부터 한 20분 정도, 약 20분 동안 간단한 토론 및 질의응답을 진행하겠습니다. 시간이 허용될 경우 참가자분들의 실시간 질문도 반영하려고 합니다. 많은 참여를 바라겠습니다. So before taking questions from the floor, I'm going to start my question. So actually, I have prepared a couple of questions for general space environment and a few more questions specifically for orbital reef. So, so Dr. Wagner, as you know well, the world is entering the new space era, and so is Korea. So Korean government has been promoting various national projects for space R&D, but now its priority is a little bit shifting to space industry led by private companies, including startups. Although we are a relatively newcomer in the space development, but Korea is one of the few countries having the technology to design and develop its own satellites and also launch vehicles. And also, as you know, we recently joined the Artemis Accord for moon exploration. So from this perspective, what do you think about current and future perspectives of Korea's space industry and ecosystem? And also, what do you think we need to do most and first to become a full-fledged space country?
I think Korea is already a full-fledged space country.
Thank you.
I want to honor that.
I
think that the history has been showing quite a bit of growth, as well as quite a bit of potential. I think that one of the really interesting things about the current era of space exploration and space industry is that we have traditionally started with exploration and science at the center of a space program, but we've had to build the infrastructure first. What's coming now is an era in which you can really focus immediately on applications. So much of the infrastructure is available, whether that is launch vehicles, communication networks, astronaut capabilities, payload hosting, so that you can really focus not on what you have to do to get there, but what you can do once you're there. And I think one of the next generation of applications is going in two very different directions. One, as I mentioned in my remarks, is that to go beyond low Earth orbit, to go to the moon or to Mars, we still need low Earth orbit as a test bed. We need to leverage that. It's about, for every kilogram you can launch to low Earth orbit, you can launch about 1/10 of a kilogram to the moon. So it really, the low Earth orbit environment is a great facilitator for training, for technology maturation, and for business growth. So I think that as we continue to reach out beyond low Earth orbit, we will see that low Earth orbit supports that. The other thing that it supports, though, is pure commercial growth. And traditionally, that has been from the basis of location. We use the space station as a place to look down. We use satellites as a place to beam signals. But what is changing now is that we are coming into the era of space as a tool as well. That microgravity really offers us the opportunity to create new materials, new alloys, new advanced manufacturing technologies that allow us to do thin layer deposition, new products. And I think that we'll see increasingly that we are thinking about the low Earth orbit economy as one where things are created in addition to the knowledge that we've traditionally created. So to take advantage of this, I think Korea has made very important strides in creating a strong industry, as well as a strong academic underpinning. And the students that are going to create these new enterprises are just starting school today. And I think that important focus on education is one that Korea has done very nicely.
My second question is associated with space safety. So as you know well, safety is a critical issue when developing commercial space station. So for example, if you consider the current LEO space environment, space debris can be very threatening. So actually last year, as you know well, there was an emergency evacuation from the International Space Station due to the menacing debris from the Russian satellite interceptor missile test. So in this case, how can you protect, or what kind of protection measure do we have for the newly developed commercial space stations against the potential threat in space?
So as a user of low Earth orbit, we're obviously very concerned about the increasing debris threat. The longer space stations are up there and propellant systems and so on, we're going to have to be investing in space situational awareness, space domain assessment. We're going to have to build in passive mitigations like shielding that are very expensive in terms of mass and cost, volume and complexity. So I think it really does come back to the international community coming together. It's a common challenge that we all face. So we're very supportive of efforts that are focused on the policy front and the efforts of nations and of companies to help ensure that we are both not creating new debris, making commitments to that future, as well as being able to track what is there now and to take appropriate actions.
Okay, thanks, Dr. Wagner. So we will enjoy now the second presentation from Ollivier Dubec. Actually, it is pre-recorded.
Hello and welcome. My name is Ollivier Dubec and I'm a professor of aeronautics and astronautics and engineering systems here at the Massachusetts of Technology. My welcome to all the participants of the Korea Strong Symposium and Workshop. It is wonderful to see you, and I'm happy to talk to you about space logistics, designing and operating complex systems in space. One of our passions for the last few years has been to analyze space logistics, but the starting point is actually Earth. So let me talk to you what I see as a clear analog for what we're doing now in space, sending astronauts commercially as well, building new space stations, going back to the moon, and establishing a permanent human presence on Mars. And that analog is actually Antarctic exploration. So let's go back about 100 years to the year 1914, where the big prize, which was the South Pole, had already been claimed by Roald Amundsen of Norway. So the British, led by Sir Ernest Shackleton, tried to cross the Antarctic continent, as you can see here, and they had a very clever concept. They sent two separate parties, one on the Endurance and one on the Aurora, with the idea that one of the parties would pre-position supplies, so when the other party came through, they could cross the continent and have 1 degree apart, every 60 nautical miles have supplies. Unfortunately, this mission failed because of a combination of poor logistics planning, no communications, and very poor physical preparation. If you're interested to learn more, there's a fantastic book on this expedition called Shackleton's Lost Men by Kelly Tyler. So we don't want to fail like Shackleton, we want to succeed. And that's why we need to think about this in a new way. The book by Peter Beck on international politics of Antarctica talks specifically about how Antarctic science is dependent on the logistics, the ability to place and maintain scientists and their equipment in the right place at the right time. Some time ago, I put together a list of all the Antarctic explorations that have happened starting in the early 1800s, and the cumulative number of these expeditions is shown on this chart. What's really interesting is that it's a kind of uneven distribution. So in the early 1800s, we had this initial discovery period between 1820 and 1840. And this was mainly coastal exploration using ships, but not really penetrating deeply into the Antarctic continent. For about 50 years then, there was a very quiet period where there was very little action. The heroic age happened in the early 1900s with, of course, Amundsen reaching the South Pole in 1911. And then after 1925, when logistics and technology were better understood, we had in-depth exploration enabled by logistics and technology. And finally, in 1957, the International Geophysical Year, you can see that permanent presence on Antarctica was established. And so to me, 1957 is the year where there was a handoff between Antarctica as being the ultimate frontier of exploration and space becoming the ultimate frontier, of course, with the launch of Sputnik. As you can see on this timeline, 1957 marks the beginning of space exploration. And we had a lot of exciting programs like Apollo and Skylab and Mir and the shuttle program, and China now with the Tiangong-1 space station. And of course, we're operating the ISS. So today we look to the future, 1960 to 2060. We look to the future with Artemis, the return to the moon with human explorers, to establishing a lunar village, to landers on the moon with payloads, to establishing the next generation of space stations, which you'll hear about as well from some of our colleagues. And finally, establishing a permanent Mars base by 2050 or 2060 at the very latest. The challenges of space logistics compared to terrestrial logistics are a bit different. In space, we have time-varying launch opportunities. We have nested complexity and the hierarchy of objects, how they're packaged, very low mass fractions. And then once you're in space, everything floats. So you have to manage your assets in microgravity. Our research group at MIT has been very active in this field of space logistics. For example, we've developed SpaceNet, a discrete event simulation environment that I will tell you about. We've also looked at generalized multi-commodity network flows as a way to create a complete system model with all the flows of materials and energy, including in situ resource utilization. Recent work includes modeling in situ resource utilization at scale, including the current MOXIE experiment on Mars that has produced oxygen for the first time. So talking about SpaceNet, we need to think about space exploration and staying in space as a network problem, as a logistics problem, just like we are on Earth. Here are 4 different scenarios that have been modeled with SpaceNet, our discrete event simulation software. And you see they include everything from ISS resupply, which has happened for the last 20 years, to future lunar outposts on the South Pole, Mars campaigns with robotic precursors, and then my favorite in the lower right-hand corner, a lunar global exploration scenario that is nomadic, where one crew, does one leg on the surface, drags essentially in caravan style their ascent stage with them, returns to Earth, and the next crew lands where the prior crew departed. You will not find this as an official design reference mission anywhere. Personally, I think it's a really exciting concept. When we look at the actual numbers of what is required to execute these campaigns successfully, in terms of number of nodes, number of edges, the number of missions in the campaign, how many critical mission events like rendezvous and docking, landing, launch, and so forth have to happen. You can see the numbers are staggering. For example, the Mars exploration campaign requires over 337 successful mission events. The number of vehicles, we call them elements or habitat elements, is also significant, both their type and their number of instantiations. And finally, the duration of these campaigns can last anywhere from a year to up to 20 years or more, as in the case of the Mars exploration campaign. So what we've learned is that we need to think of this as a network problem. we cannot bring everything from Earth. That's not sustainable. And we also need to harvest local resources. What is very exciting for us is, and you'll hear more about this from our colleague Erika Wagner, Dr. Erika Wagner, is the development of new commercial space stations. And an example of that is the Orbital Reef Station, whose development is led in a partnership by Blue Origin and Sierra Space. And we're very proud to be part of that team to helping establish the logistics strategy for this really exciting future space station. And so we're currently working on different scenarios, establishing the feasibility and the credibility of the campaign plan. And so you see that SpaceNet is very useful here in establishing, you know, how much cargo can be sent or must be sent to the station? What are the demand models? How much cargo is available for customers on this commercial station beginning in 2026? And so this is really a new age of space logistics. And it's very exciting to see many of the ideas that were just proposed theoretically some years ago actually coming to fruition. Talking about Blue Origin, we're also very excited to have participated in some of the now suborbital flight opportunities. For example, in New Shepard, the suborbital vehicle last August 2021, we were able to successfully demonstrate the transfer of fuel from one tank to another in microgravity. And you see the mission profile here. You get about 3 to 4 minutes of pristine microgravity, and it's extremely useful, not just for space tourism and observing the Earth from space, but also for conducting high quality science in microgravity. So you see our team of students here very excited after the successful flight in the desert in West Texas. So as we think beyond orbiting stations, obviously the ultimate destination for human settlement beyond the Earth is Mars, the red planet. Here you see a concept for Star City. This is a settlement on Mars proposed by Dr. George Lordos, one of our colleagues, and students in the current engineering systems laboratory. His idea, which won first prize in the Mars City design competition a couple of years ago, is to find a crater about 1 to 2 kilometers in diameter and essentially to dig tunnels into the rims of that crater. You can see the different colored lasers here represent different villages in that settlement. Each color is a different continent, like Asia, Europe, Americas, and the idea is that you could see these lasers from Earth. As we look deeper inside to the settlement, we can see a network of tunnels. These tunnels have different colors, and the colors indicate the different functions that these tunnels would have, such as working, living, repairing equipment, and of course, in green, producing food. This is essential. So producing the food, the plants, the caloric intake that humans need to live. And so managing the seeds, the plant growth, the water cycle carefully in such a habitat isn't just useful for space logistics and space exploration. It will also help us be more sustainable here on planet Earth, our current home. And so this thinking in terms of circularity and efficient use of resources is in fact very helpful back here on Earth. So I want to tell you about this project. It's a JWAFS project. That's the Jameel Water and Food Security program here at MIT, where we've analyzed system analytically using these system modeling methods, small farms, animal waste recovery strategies. In southern Brazil, for example, you can see here on the left side, the Paranha River, which feeds the famous Itaipu Dam. There's a lot of agriculture, animal agriculture, cows, chicken, and pigs as well. And there's a lot of animal waste that is collected. Right now, much of that animal waste is essentially carried by rainwater into the river, which is not good for the environment. So here the strategy is to collect the animal waste into a network, to put the animal waste into so-called biodigesters. And from this, we can produce biofertilizer in the form of pellets, which is fed back into the fields for crop and fodder production. On the other hand, the biomethane that is produced can then be used for either stove cooking, electricity, clean electricity generation on the power grid, as well as upscaling it to compressed natural gas for the transport of vehicles. The key question is whether this closed ecosystem is in fact financially sustainable as well, and what the payments for these environmental services could or should be. The value, of course, here is not just in the biomethane, the electricity, the fertilizer that's produced, but it's of course in also the avoided water pollution. And so this work was presented last year at the AGU, that's the American Geophysical Union, and has been very well received. So in a nutshell, we are learning from space as we are living and working in space sustainably. We are learning and bringing that learning back to our home planet, Earth. And so with that, I'm very excited to participate in the Korea Strong Forum. I hope you enjoyed this presentation and looking forward to a great Q&A session with everybody. So with that, thank you very much and all the best.
Okay, thanks, Professor Olivier Dubec, for the second presentation. And I feel sorry that he couldn't join our conversation and Q&A period. But anyway, during the second presentation, we have several questions from the floor. And then I'm going to send one of them to Dr. Wagner. Is it okay to you?
Wonderful.
지금 플로어에서 한 5개 질문이 올라왔는데요. 그중 하나가 물론 추천은 많지 않습니다만 사실 그 오비탈 리프 측에서도 상당히 좀 흥미로워할 질문이 아닌가 싶어서 선정을 했습니다. So, Dr. Wagner, could you answer for this question?
Wonderful. Thank you for the question. I think when we talk about Korean companies joining the orbital reef, it can happen at many different levels. We will have suppliers that are helping us to build the space station, but we will also have business partners who are helping us to increase the kinds of commercial utilization that is happening on the space station. So companies could come and fly astronauts with us. They could come and conduct experiments. They could test hardware that is serving commercial markets. They could even build their own modules. You could imagine a space station module that is a hotel or one that is a laboratory. Those possibilities are all wide open. So when we think about the skills that are necessary, I think that the Korean infrastructure already has these. And we're really very excited to think about how we bring those together with the infrastructure of the orbital reef to help realize those business objectives.
Thanks, Dr. Wagner. And I'm going to send one more question. Okay? 하나 더 질문을 드려보려고 하는데요. 플로우에서 올려온 것 중에 추천이 2개가 있는 건데요. 이것도 좀 설명을 해주시면 좋을 것 같습니다. 1인 우주선으로 우주정거장에 참여하려면 어떤 준비가 필요할까요? 참여 기준이 있나요? 라는 질문이었습니다.
This is one I'm personally very excited about. The single-person spacecraft looks very much like a small deep-sea submersible, and it is really designed to be used with very minimal training. The prototypes are being used in underwater testing right now, and we are working towards the first applications that would be in space. But they are designed so that a user can climb inside with no spacesuit and can either operate the vehicle themselves or be remotely operated. So you could imagine that if you are a trained operator, you might go to the outside of the space station for inspections or maintenance. If you are a researcher, you might go outside to conduct your research. Or if you are a tourist, you might come in and be driven around the outside of the space station for a tour so you could see the Earth from new perspectives and see the space station from different perspectives. So it is our hope that this, unlike a traditional EVA, which requires nearly a year of training, this should be something that any tourist could participate in.
Okay, thank you. 사실 이 시간 제한도 있고 해서 질문을 마치려고 했는데요. 지금 한 가지 질문에 대해서 계속 추천이 수가 늘어나고 있습니다. 그래서 마지막으로 한 가지 질문을 더 보내겠습니다. Dr. Wagner, I have to send one more question. This must be the last. 그 질문은 뭐냐면은 사실 제가 한 질문하고 첫 번째 질문하고 약간 오버랩이 되는 것도 있는데요. 한국의 우주를 향한 기술 수준은 글로벌 국가에 비해 어느 정도 수준인지, 그리고 두 번째로는 앞으로 우주정거장 운영에 어떤 역할을 할 수 있을 것이라고 생각하시나요? 라는 질문이었습니다.
So I think that the wonderful thing about the commercial LEO destinations ecosystem is that there really is a very, very wide range of roles. As I mentioned before, I think that we are looking at traditional roles for suppliers in the aerospace field, but the growing roles, the new opportunities that are emerging are really for all companies. And to really re-envision all of our terrestrial businesses and ask, how would my business run in space? Whether that's hospitality or entertainment or electronics or manufacturing, materials or biotech. So I think that there are a very wide range of applications. And the skills that are needed to make that transition from a terrestrial application to a space application are ones where we are growing the bridges right now. So how do you move from a laboratory that works on the ground to one that works in microgravity? Well, you need to learn some of the fundamentals of how the systems change. You need some help in adopting a technology so that things that normally sink and float don't do that in space. We have to create systems so that they can be managed without convection, without sedimentation. But that opens up a very, very wide range of new things we can learn, new things that we can create, and new businesses that we can form together. So I think that it will be a very exciting time in the next few years as Korea decides what opportunities it wants to grow in low Earth orbit.
Okay, now I'm going to proceed my question, specifically for orbital reef. So Dr. Wagner, as you know well, actually there are several companies to develop commercial space stations, right? Including Axiom Space, NanoRex, Northrop Grumman Systems, and so on. So for example, a commercial space station developed by the Axiom Space is currently under construction and planning to launch its first module in late 2024. So from this perspective, could you highlight unique features of orbital reef compared to other commercial space stations?
Right. So orbital reef is a free-flying space station. It's designed commercially to start floating in space, not attached to the International Space Station. And so we have the opportunity to innovate and start fresh in many ways. Using the New Glenn launch system, as I mentioned, we have a 7-meter fairing that allows us to have larger modules that support new kinds of applications. Because the ISS has its infrastructure on the outside, it relies very heavily on extravehicular activity for things like maintenance and operations, which is very difficult and expensive. So we have put much of our infrastructure on the inside of our spacecraft. It's a very simple change, but one that really dramatically changes the cost of operations and maintenance. Also, much of what drives the cost of operations in low Earth orbit really is logistics, getting things to and from, making sure you know where everything is, having access to it. So we've partnered with one of the world's leading experts in logistics, working with Amazon, to rethink logistics for the commercial space age. And the last piece I'll mention is that we practice what we call open vertical integration. So our space station team is designed to offer an end-to-end service solution. We have launch and transportation, infrastructure, laboratories, habitation. But we're also building a business model that is open. And that really means that commercial service providers in Korea and elsewhere around the world can provide astronauts, can provide vehicles, can provide modules and payloads and operations to build their own businesses. So I think that that mixture of a end-to-end service provision with open opportunities for collaboration really is a unique one.
Thank you. My second question is about the Orbital Reef team. And the Orbital Reef team is planning to complete and deliver the baseline configuration of Orbital Reef in 2030. And this timeline seems to be pretty much tight, even to me, who is familiar with so-called the quick sort of mindset. Many obstacles can be expected since more than 6 companies are jointly participating. So in that case, how did you manage risk factors such as delays in timeline or difference of opinions in technical design and so on?
Yeah, it is ambitious and it is bold. And it, in fact, is even bolder than you state, because NASA has said that it wants to begin to transition operations off of the International Space Station as early as 2028 so that it can close down operations in 2030. So we have to be up in advance of that transition, and we have committed to doing so. So I think that we have really started with essential technologies are well understood. There is not deep technical innovation that is happening here. What is really innovative is the way that this is being built up as a system and as a business. So we need investment, experience, and creativity, commitment, and all of which we have in large amounts in this team. I think that it also means that we have to act commercially. The space station took a very long time to be designed and to be launched because it was a slow and steady pace. But we are working in a commercial frame of mind. So that means we have parallel development, both traditional gated reviews, our preliminary design reviews and critical design reviews that are milestones with our customers at NASA, but also what we call hardware-rich development. And that means that we are already cutting metal, we are already prototyping, we are already working through the operations of the system so that we can, in parallel, be moving as fast as possible.
Okay, quite interesting comment. 근데 시간이 지금 1분 채밖에 안 남았어요. 그래서 I think we just have a couple of minutes, so this should be my last question. I'm also interested in the design of Orbital Reef because its design seems to be quite different from the current International Space Station. So basically, its functions are significantly expanded from just scientific research from various business models, such as space tourism, microgrid manufacturing, and so on. So many technical improvements will be necessary to realize this kind of new concept, sort of space station. So from this perspective, what do you think the biggest technological challenge of Orbital Reef project? So could you explain it by introducing a couple of examples?
Right, so the Orbital Reef really is a next generation facility. It has this open system architecture that allows for any nation or industrial customer to lease space on the reef. And we use standard interfaces to enable that growth so that you can bring your own module or commission ours, bring your own payload or work with us. And so being able to grow indefinitely as the market grows is really one of the big changes here. We've really been thinking a lot about how you would take core modules and add additional core and mast modules so that you can add additional applications and additional tenants so that there's always enough power and cooling, life support and communications to grow those applications. So as we open up that main thoroughfare, that main corridor with more core modules, now we can add additional storefronts onto our mall or onto our business park. So everyone has a view of the Earth, everyone has the infrastructure that they need, but we can continue to grow and support those new applications. So that's a very big focus of ours.
Okay, thanks, Dr. Wagner, for very interesting presentation and answering many questions, and also suggesting a piece of advices. Thank you.
Thank you so much.
제가 조금 시간을 초과했는데요. 비록 짧은 시간이었지만 인류 삶과 경제 활동을 위한 우주 활용, 그리고 이것이 우리에게 남겨준 과제를 살펴볼 수 있는 아주 유용한 기회였던 것 같습니다. 오늘 오비탈 리프를 메인 주제로 참여해 주신 와그너 박사님과 드베크 교수님에게 다시 한번 감사를 드립니다. 그리고 이 기조 세션이 끝나고도 우주 경제에 관련해서 많은 세션이 있으니까 많이 참석해 주시기를 바라겠습니다. 이것으로 기조 세션을 모두 마무리하도록 하겠습니다. 감사합니다.
네, 고맙습니다. 수고해 주신 좌장님께도 여러분 다시 한번 큰 박수 부탁드리겠습니다. 네, 고맙습니다. 사실 우주라는 단어만 들어도 가슴이 설레는데요. 이 우주가 갖고 있는 무궁무진한 기회 그리고 가능성에 대해서 진솔한 의견들 그리고 질의응답까지 함께 진행을 했습니다. 우주정거장이 더 이상 먼 이야기가 아니라 더 많은 사람들이 친숙하게 여길 수 있는 공간이어야 한다라고 말씀을 또 해주셨는데 안전과 또 설계, 운영까지 다양한 또 중요한 키워드 함께 짚어주셨습니다. 앞으로 우리는 달로 가고 또 화성으로도 가겠죠. 오늘 이 자리를 통해서 그날이 조금 더 빨리 오지 않을까 하는 생각도 듭니다. 고맙습니다.